shows up in both x and y. Sine of phi is equal to opposite over hypotenuse. So if you look at the right triangle that I have drawn in blue right now, the opposite is that direct short distance to the z-axis, and the hypotenuse is rho. So I'm just going to leave this labeled opposite right now, but we know the hypotenuse is rho. So rho times sine of phi is equal to that opposite side that we have labeled here, okay? And then from the point that's projected from that point into the xy plane, if you can draw a right triangle to the x-axis, you can also draw a right triangle to the y-axis. And I know that it's, especially because, again, when I was talking about z, I was trying to get you to see the right triangle that's, a right triangle that's there, so I kind of focused on drawing it like the right triangle. But again, that's the benefit of us having our little diagrams here, that if, you know, here's some random points, okay, in space. And if I'm going to go straight to the z-axis, look, that's the length I'm drawing, okay? It is perpendicular to the z-axis. But notice, it's what my finger was just tracing is the same as this. Okay, I mean, if you project it down into the xy plane, so again, here's my random point out in space. I'm going to draw the shortest distance to the z-axis. That's my shortest distance to the z-axis. What I just traced, if I transpose that to the xy plane, it is this right here, okay? So for theta, cosine of theta is adjacent over hypotenuse. But in this case, the adjacent for theta, the adjacent is x. Okay, this side is giving me my x coordinate, and it's adjacent to theta. And the hypotenuse is what I have labeled op up there. What I have labeled as op is what I was just talking about here. Here's my random point. There's the shortest distance to the z-axis. That distance that I just traced is this hypotenuse in the xy plane. So that is equal to rho sine phi. So rho sine phi times cosine theta equals x. And then for this triangle, well, actually, I don't even have to necessarily draw. We could work off of that, but if I stay in this triangle, this leg of the triangle is the y coordinate. It's the same as the length of the leg over there. So sine of theta is opposite over hypotenuse, but for this triangle, the opposite is y. The hypotenuse is still rho sine phi, and so rho sine phi times sine of theta equals y. Okay, so that's where these are coming from. All right, if you haven't, I mean, I think you guys have probably been in math and science classes enough by now to know that it's a lot easier to hold on to formulas if you sort of realize where they come from. So, am I going to ask you to prove those on tests? No, but if you're trying to learn them, it's probably worth your study time to kind of go back through the little